Alright, Algebra 2 class. Today's lesson is going to be on congruent and similar figures. So we're going to review a little bit of geometry that you guys learned last year on congruency and similar. So my objective or my learning goal for today is to identify and use the word, or use congruent and similar figures. So you're going to need to know what the difference is between congruent and similar. Think about what the difference is right now if anybody knows. Okay, so here's the definition of congruent. Congruent figures have the same size and the same exact shape. Okay, so get my highlighter out here. They have the exact same size and they have the exact same shape. Okay, the two polygons, polygon, just like polynomial, many terms, polygon, many sides. So the two, and it doesn't matter how many sides, it just has many. And then there's specific ones like triangle, square, so forth. Two polygons are congruent if their corresponding sides and their corresponding angles are congruent. So corresponding means in the same position. So let's look up here, angle B. If you guys look at angle B, that's this guy right here. Okay, notice he has one arc on him. Okay? Where on this triangle would be, what would be corresponding angle to angle B on this triangle? And you see how angle F would be the corresponding angle? Because there's one arc. So angle B corresponds to angle F. Let's pick another angle here. Let's go angle D. So angle D has 3 tick marks on it. So what angle would correspond to angle D here? And you see how angle C has 3 tick marks, so those would be the corresponding angles. And then what's the third set of corresponding angles here? Angle E and A, because each one of those have 2 arcs. So the arcs tell you, the number of arcs tell me which ones are corresponding. Okay? So we got A and E are corresponding here. We got B and F corresponding here, and we got angle C. And they're congruent actually, so they're both all the same. Angle C is congruent to angle D. Okay? The sides also correspond. So do you see how we have one tick mark right here, which would be segment BC? Well, what segment would be the congruent part on the other one? And you see how it would be, so if I went BC, that's green to blue, I'd say FD is congruent to that. So BC is congruent to FD. Okay? You can do the same thing for the other one. So AC, so yellow to blue, or 2 tick marks, 2 arcs to 3 arcs, and then 3 tick marks in between there. Well, the 3 tick marks are right here, so 2 arcs to 3 arcs. So AC is congruent to ED in the same order that you see them. Okay? And the symbol with the squiggly above the equal sign, that's called congruent. So if ever you see this, it doesn't say equal. This says angle A is congruent to angle E. Okay? So if I'm going to say these triangles are congruent, I have to match up the corresponding parts of the congruent triangles. So if I say triangle A, B, C, okay, if I went that direction, where would I have to start if I start with angle A in the first spot here? I have to start with angle, so 2 tick marks, so E, so I'd start at E, and then what's the middle angle here? And it's angle B, so that would be the 1 tick mark. Okay, so then what's the middle here with 1 tick mark? It'd have to be F, so you have to go from here to here to here. Okay, the order matters when you label those. You have to match up the corresponding parts, so the corresponding sides, corresponding angles, when you match them up. Okay, you can pick any angle. I can pick a different triangle. I could call it triangle CAB. Okay, if I say triangle CAB is congruent to, well, what corresponding angle matches up with angle C? So C is here, that's 3 tick marks, so that'd have to be D, so I have to start with the D. Angle A would be next in my order, so angle A has 2 tick marks, so which one here has 2 tick marks? E. Okay, B is my last one here, B has 1 tick mark, well, E here has 1 tick, or what letter is this? This is an F, sorry. Yep, that's an F down here. So this is an F with 1 tick mark, so then F would be right there. So this is another way of writing this triangle, these two here. two different ways of writing the same congruent triangles. And there's multiple ways. As long as you do the correct order, you are correct. Okay, so congruent means same size, same shape, nothing's changing. Okay, each one of your desks are congruent. The tops of them are probably. Same size, same shape. Okay? So the corresponding parts of two congruent triangles are marked on the figure below. Write a congruent statement for the two triangles. Okay, so I'll let you do that on your paper right now. Give you 30 seconds here. Ready, and go. Okay, I'm doing three separate ones. You might not have any of these three. You might have a different order of my letters. What matters is the corresponding parts match up. So if I go A to B to C, A would be 3 tick marks, B would be 2, C is 1. So 3 to 2 to 1. So on the other one it would be 3, which is D, to 2, which is E, to 1, which is C. Okay? Or I could start with B, so B to C to A. So B is 2, C is 1, A is 3, so 2, 1, 3, so 2, 1, 3. So E is 2, C is 1, and then D is 3. CAB would be 1, A is 3 to 2, so 1 to 3 to 2. So I gotta go 1 to 3 to 2. So C to D to E. Okay? Those are three choices. You could have more. Okay, but just make sure you match the exact same parts and you go in the same order around your triangle. Okay? So we just defined congruent, which is probably what I'm going to ask you tomorrow on the bell ringer, the difference between congruent and similar. So similar, so we just talked about congruent. Now similar is different. Similar says that the figures have the same shape, but are not necessarily the same size. So an example of a similar figure could be a volleyball and a tennis ball. Both are spheres. One's a lot smaller than the other, but they're the same shape. They're both a sphere. Depending on the ratios of sides, books could maybe be similar, certain types of books. My clock in the front of the room over here with the yellow math equation is similar to my clock over here. Okay, same shape, it's a circle, different sizes. Okay? So, when you guys do these, you're going to have to make sure that they have the equivalent ratios when you're doing them. Okay? Corresponding parts are equivalent. So if I look up here, where would side 4 correspond to? And it's in between the arc of 1 tick marks and the arc with 2 tick marks. So where's the arc with 1 and 2 tick marks? 1 here, 2 here. So 4 and 2 are corresponding sides, but we have to make sure that they are proportional. Okay? So mathematically, how would you get from a 4 down to a 2? You said you can divide by 2. Okay? What side does 6 correspond to? That's between the 2 and the 3 tick marks. 6 and 3 correspond. So now from 6 to 3, did I also divide by 2? Yep. And then that means that 8's left over with this 4. Do you divide by 2 to get from 8 to 4? And you would. So therefore now, that makes those triangles similar. Okay, and the symbol for similar is a little squiggly without the equal sign. Okay? So the sides have to be proportional, which we just checked, they all divide by 2. Another way of doing that would be the big triangle over the little triangle equals the big side over the little side. These are the corresponding parts. And then the last one would be the big side over the little side. So 8 over 4. And all those simplify into 2 over 1, 2 over 1, and 2 over 1. So they're all the same, they're proportional. Okay, let's try this one on your paper quick. Just jot down the answer. Determine whether the polygons are similar right up here and justify your answer. And are they similar, yes or no, and then why or why not? Are they similar? And the answer here is no. Are they the same shape? Is the rectangle the same as a parallelogram? These angles aren't the same, are they? So automatically when they're not the same, then no, they are not similar polygons. Alright, you'll have a couple problems like this today on your assignment. So it says, solve a problem involving similarity, civil engineering. The city of Mansfield plans to build a bridge across Pine Lake. Okay, this right here is Pine Lake. Okay, use the information in the diagram at the right, and the reason why it says at the right is because this picture used to be over here, but I have now moved it down here so I can do some work, to find the distance across Pine Lake. Okay, if you look up here, there are actually, what you might need to do when you're doing problems like this is you're going to have to draw out the triangles. Okay, so if I look up here, one triangle that I have, I see, is this triangle right here. The big triangle. So I'm going to bring the big triangle over here. And let's label the parts of that big triangle that I know. So how long is this side from here to here, the entire side? And it would be 100 plus 120, which would be 220. Okay, do I know anything else here? I don't know this side x here, so I'm going to call that x here. Now let's look at the small triangle. Do I have a small triangle right here? With the right angle? Yep, so I'm going to bring him over here. And I'm going to label him as well. So what are the parts that I know from this guy? We got 100. And we got 55. Okay, so on this problem, these triangles are actually similar, if you remember from geometry last year, by angle-angle similarity. What that means is they both have a right angle, so here and here, and then since they share this common angle up here, this angle is congruent to this angle, so they're angle, 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 so then they'd be proven similar by angle, angle similarity. Which means if they're similar, we can do a little proportion action, and that will get me the solution. So what I do here is I take, usually what I do for my proportion is I pick up corresponding parts, so 100 would correspond to which side here? The 220. So I'd go 100, small, over big. So this is my small, over big. So small over big here. So small over big here equals, I gotta do the same ratio. So if I went small over big here, what do I have to start with on the top of my fraction of the other, on the other side? Small over big, so small side of this guy here would be 55. And what does the 55 match up to? The x. Okay, so now I got small over big and small over big. How do you solve a proportion in math? Cross what? Multiply. So, what does it get when I do that? I get 100x. And then you put an equal sign in between that cross product. And then I'm going to multiply here. And I don't know that off the top of my head, so you guys are going to get your calculator out, just like me. Okay. And what do I get when you take 220 times 55? 121, sorry, 12,100. And then my final step to get x by itself would be divide by 100. So that means that x equals 121 meters. Okay, and that is how long my bridge would have to be spanning across that lake. Questions on that? Alright, good luck. Here's your assignment.